In this session, we are going to cover regression and correlation. I'm using Rice University's demonstration website to do this. So first, let's focus on the right-hand side. The regression line, the fitted line y hat equals b0 plus b1x. And if the slope is 0, that is b1 is 0, then the fitted y hat equals y bar. And correlation coefficient, we are going to cover Pearson's R in this demo. And R squared is called the coefficient of determination. And R squared is actually a ratio. It's a ratio of explained variation divided by the total variation. The total variation is the sum of explained and unexplained variation. So the total variation is the variation of the y values around its mean. And explained variation here is how much the fitted line or the regression line, how much it deviates from y bar. And the unexplained variation is the scatter or the variation of y values around the fitted line. Okay. Now, let's focus on the left-hand side. We've got an xy scatter plot. We've got x variable on the x-axis, y variable on the y-axis. As you can see, there's not a lot of relationship between x and y. And we are going to focus on three things here. The slope, in this case, slope is 0. And then we are going to look at Pearson's R, in this case, it's 0. And then we are going to look at the unexplained and the explained portion of the variation. So in this case, there doesn't seem to be a relationship between x and y. So if we fit the regression line, the slope is 0, so y hat equals y bar. So what that means is, if you ask me what is the best predictor of y, I would say it is y bar. Okay, so y hat equals y bar. So that's a fitted line. And the Pearson's R is 0. There is no correlation, so it's 0. And the unexplained variation 100, so that is the total variation of all the y values around its mean. That's a total variation. And in this case, unexplained variation is it's a variation of these data points around the regression line. So the regression line in this case is y hat equals y bar. So the total variation is exactly equal to an unexplained variation. So 100% of the variation in y is unexplained. Okay. So now let's make the slope to be 0.5. So there is a slight positive slope here. So regression slope is 0.5. And Pearson's R is 0.44. And when you square that 0.4 squared, that's about 16%. So what is shown here is about 16% of the variation y is explained by the relationship between x and y. So there is still a lot of scatter. So 84% is there's a lot of scatter of the y values around the regression line. So that scatter, that represents 84%. 16% is the slight positive slope here, how much it deviates from the horizontal slope of 0. So now let's make the slope 1. Then you see that the Pearson's R is 0.7. And when you square that, that's 49%. So almost half the variation is explained by x. The other half is not explained. So unexplained variation is 100 units. You can see here, explained is 100. Okay, so remember these numbers. Remember the 707. So now I'm going to change the slope to 2. Now you see that the correlation, Pearson's R is 0.89, so almost 0.9. And the unexplained variation is still 100. But you can see explained variation significantly increased because the slope significantly increased from 0. So this 0.9 square, so that's almost 80% of the variation explained by x. Other 20% is unexplained. And then if I make the slope 3, again you see that unexplained portion is exactly same as before 100, but explained part significantly higher now. And the Pearson's R is 0.949. So when you square that, so you see that 90% of the variation Y is explained by X. Okay? So now let's play around with this standard error or the variation of these data points around the regression line. So currently it is 10. So I'm going to make a half, I'm going to make it 5. So now the variation around the regression line, it has significantly reduced. Now you can see that the Pearson's R has increased 0.986. And then when you square that, you see that more than 98% of the variation explained by X. Very small percent is unexplained. So the slope is still the same. When we decrease the standard error from 10 to 5, the regression slope is the same, but the variation around the regression line has reduced. So Pearson's R has increased and R squared also has increased. So now if I make the standard error 0, so that means that there is no variation of the data points around this line. All the points lie exactly on the straight line. So that means that I have a perfect linear relationship between X and Y. So the slope is still the same, 3, but you can see Pearson's R is 1 and R squared is actually 100%. So what this means is that if you want me to predict Y, I can perfectly predict. You just give me the value of X, then I can predict Y based upon this linear relationship, and it's a perfect prediction. Okay? So in summary, we explained the relationship between the explained unexplained variation and the slope, regression slope, and Pearson's R in this demo. Thank you.